At the end of this topic, you will be able to define the force experienced by current-carrying conductor placed in a uniform magnetic field. State and explain Fleming's left-hand rule. Describe the construction and working of an electric motor.
We have learnt that current-carrying conductor behaves like a magnet on passing current. Now, let us discuss the effect of external magnetic field on the current-carrying conductor. What happens when current-carrying conductor is placed in an external magnetic field? Yes, they experience a force. This force deflects the conductor or moves away from the magnetic field. This mechanical force experienced by a conductor placed in a magnetic field depends on the strength of the current I, length L of the conductor, and the magnetic induction B of the external magnetic field. Therefore, force F is equal to BIL. Now a question arises. What will be the direction of the mechanical force? The direction of mechanical force can be found from Fleming's left-hand rule. Stretch the first 3 fingers of your left hand such that the forefinger, middle finger and the thumb are mutually perpendicular to each other as per visual. If the forefinger shows the direction of the magnetic field and the middle finger points the direction of flow of current, then the thumb points the direction of the mechanical force. By applying Fleming's left-hand rule, one can find the direction of mechanical force. This rule is also called as motor rule. Electric motor is a device that converts electrical energy into mechanical energy. Let us now discuss the construction of DC motor. The main part of a DC motor is the rectangular coil of insulated copper wire wound on a soft iron core. This arrangement is called the armature. It has permanent horseshoe magnet, 2 metallic half rings called split rings forming the commutator and 2 carbon brushes. These parts are fixed as shown in the visual. The battery, key, brushes, commutator and the coil form an electric circuit. Now we will see the working of DC motor. Consider the armature coil is in horizontal position. That is, the plane of the coil is parallel to the magnetic field. If the current flows in direction A to B and C to D, AB experiences downward force and CD experiences upward force. This constitutes a couple and so rotates the coil in anti-clockwise direction. Due to the rotation, the coil is turned through 180 degrees, and the arms AB and CD have interchanged the positions. Commutator has changed the current direction. Now CD will be in the position of AB. Thus, CD experiences downward force and AB experiences upward force. Similar action will take place and further rotation continues if the current is supplied continuously.
In the case of commercial motors, we make use of electromagnets instead of permanent magnets. Large number of turns of conducting wires in the current-carrying coil and a soft iron core on which the coil is wound. The rectangular coil of insulated copper wire wound on a soft iron core is called the armature. These factors increase the power of the motor.
In this topic, you have learned when a current-carrying conductor is placed in a magnetic field, it experiences mechanical force. Stretch first 3 fingers of left hand mutually perpendicular to each other. If the forefinger denotes the direction of magnetic field and the middle finger denotes the direction of current, then the thumb represents the direction of mechanical force. This is Fleming's left-hand rule. Electric motor works on the principle of current-carrying conductor placed in a magnetic field experiences mechanical force. Electric motor is a device which converts electrical energy to mechanical energy.